Hello learners, I am Pankaj Kumar Swarnakar, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you all again to the course Fundamental of Building Construction. In this lecture, we will focus on lintels and arches with the following key points. Introduction to openings in the wall, classification of lintels, arch construction and terms, stability of an arch, classification of arches. So, let's discuss introduction to openings in the wall. In the construction of buildings, opening in the walls are essential for installing doors, windows, cupboard, wardrobes and similar features. These openings are typically supported by structural element known as lintels or arches. Both serve the purpose of carrying the load of the wall section above the opening and transferring it to the adjacent side wall, which is referred to as jambs. So, one question which may be coming to your mind, how we can define a lintel? A lintel is a horizontal structural element placed across the top of the opening, functioning similarly to a beam. Means we can visualize lintel as a beam which is simply supported at two ends. The width of the lintel aligns with the wall's width and its ends are embedded into the wall. The minimum bearing length, what is the bearing length? Bearing length is nothing but portion of lintel resting on the wall is known as bearing length. So, the minimum bearing length should be determined by following criteria. The first criteria is minimum bearing length should be 10 centimeters or 100 mm. Second criteria is the height of the lintel. Third criteria is 1/10 to 1/12 of the lintel's span. Conversely, an arch is typically a curved structure formed by wedge-shaped unit that interlock and support each other. I think you can visualize better in this picture. These units are supported by abutment at both the ends. However, arches made of steel or reinforced concrete can be constructed as single rigid unit without the use of traditional wedge-shaped component. Arches can also be flat, constructed from brick or the masonry. Now, we will discuss about lintel. Lintels are generally simpler to construct, while arches required specialized centering or formwork because of curvature involvement. Arches are preferred when the loads are heavy, the span is large, strong abutments are present, or a particular architectural style is desired. Now, we will discuss about the classification of lintels. Lintels can be classified based on the material used in their construction. So, we can classify lintels based on material used as timber lintels, stone lintels, brick lintels, steel lintels, reinforced concrete lintels. We are going to discuss these classification one by one. First one is timber lintels. Timber lintels are among the oldest type, though they are less commonly used today. We can see timber lintel rarely in hilly regions, but in most of the cases they are obsolete. These lintels are more expensive, structurally weaker and susceptible to fire, which is the biggest disadvantage with the timber lintel. Additionally, they can decay if they are not properly ventilated. Timber lintels can be constructed by joining together multiple pieces of wood with steel bolts or by using wooden pieces separated by wooden spacers. To enhance their strength, mild steel plate are sometimes added to the top as well as bottom of the timber lintel. In this type of arrangement, the strength is enhanced and this type of arrangement is known as flitched lintel. Now, the next one is stone lintels. Stone lintels are commonly used particularly in the areas where stone is readily available. A stone lintel consists of a thick stone slab. Stone lintels can be placed over openings in brick wall. An dressed stone lintel offer an aesthetically pleasing architectural appearance. Stone lintels may be constructed from a single piece or multiple pieces across the width of the wall. Means we can understand, if we are having width of the wall equal to width of the stone, then it can be constructed as single piece, but if the width of the stone is less than width of the wall, then we have to go for multiple pieces of the stone. The depth of the stone lintel is typically 10 centimeter per meter of span with a minimum depth of 15 centimeters. Stone lintels are generally used for a span up to 2 meters. For wider span, stone slab may be placed on the edge. Since stone is weak in tension and prone to cracking under vibratory load, stone lintels should be used with caution in areas where such type of load, means vibratory kind of loads, are common. Now we will discuss brick lintels. Brick lintels are not particularly strong and are used only for small opening. What we understand by small opening means, if the opening span is less than 1 meter, then only we are supposed to use the brick lintels. A brick lintel is formed by placing bricks on their ends or edges. The depth of a brick lintel typically ranges from 10 centimeter to 20 centimeter. Depending on the span, brick lintels are constructed over temporary wooden centering, and brick with the frogs are preferred for construction. When filled with mortars, the frog from joggles which enhance shear resistance of the joints, creating what is known as joggled brick lintel. Now we will discuss about steel lintels. Steel lintels are employed when the opening is large and the superimposed loads are heavy. Steel lintels consist of rolled steel joist or channel section, either used singly or in combination. When used singly, the steel joist is either embedded in concrete or cladded with stone facing to match the width of the wall. When multiple units are placed side by side, they are held in position by tube separators. Now the last one is reinforced concrete lintels. So reinforced concrete lintels have largely replaced all other type of lintel. Why? Because of their strength, rigidity, fire resistance, economy and ease of construction. These lintels means reinforced concrete lintels can be used for any span and their width matches with the width of the wall, so that it will look elegant. The depth and the reinforcement of reinforced concrete lintel depend upon the span and the magnitude of the load. Longitudinal reinforcement, typically mild steel bars, is provided near the bottom of the lintel to resist the tensile stress. I think you can understand. We can visualize this RCC lintel as a simply supported beam. So when simply supported beam is subjected to uniformly distributed load, so the bending moment diagram will be parabolic and the nature of bending will be sagging, causing tension at the bottom and the compression at the top, because of which longitudinal reinforcement are provided near the bottom of lintel. At the same time, we have to take care for the stresses. So some of these longitudinal bars are cranked near their ends and shear stirrups are added to resist the transverse shear. Reinforced concrete lintels are available as precast units, though cast in situ units are more common, requiring foam work for construction. For cavity walls, reinforced concrete boot lintels may be used, offering a better appearance and reducing the amount of concrete required. However, the toe section of the boot lintel must be strong enough to bear the load. A flexible damp proof course, which is known as DPC, is provided above the lintel to prevent the seepage of water. Now we will discuss about the arch construction and terms. So, an arch is a structure made of wedge shaped unit, typically bricks or stone, joined together with mortar and spanning and opening to support the weight of the wall above along with any additional load. The wedge shaped unit in the arch support each other and the load makes them more compact, enabling the structure to transmit the pressure downward to the supports. Arches are architectural and structural element that span an opening and are designed in a curved form. Unlike lintels which are horizontal, arches are typically semicircular, segmental or elliptical, and they distribute the load through the curved nature, pushing the weight outward and downward to the abutment or supporting wall. The major advantage of using the arch is, if we design the arch in the proper manner, the complete arch will be under the compression stress only. Now, this construction of arch involves three critical steps. One is installation of centering, second is laying or casting the arch, third one is removal of centering. There are several technical terms which are associated with the arch construction. We will discuss each term one by one. First term is intradose. What is intradose? Intradose is inner curve of an arch. Second is soffit, the inner surface of an arch, often used synonymously with intradose. Now, what is extradose? Extradose is outer curve of an arch. Next is voussoirs, the wedge shaped units forming the arch known as voussoirs. Next is crown. The highest part of extradose is known as crown. Next is key. The central wedge shaped unit at the crown of the arch is known as key. Next is spandrel. The curved triangular space formed between the extradose and the horizontal line through the crown is known as spandrel. Next one is skewback, the inclined or splayed surface on the abutment from which the arch springs. Next is springing points, the points from which the curve of the arch begins, known as springing points. Next is springing line, an imaginary line connecting the springing points on either end is known as springing line. Next is springer. So, what is a springer? The first voussoir at the springing level adjacent to the skewback known as springer. Next is abutment. The end support of an arch is known as abutment. Next is pier, an intermediate support in an arcade known as pier. Now, what is arcade? Arcade is a row of arches in the continuation. Next term is haunch, the lower half of the arch between the crown and the skewback is known as haunch. Next one is ring, the circular course forming the arch which may consist of one or more rings. Next one is impost. The projecting course at the upper part of a pier or abutment emphasizing the springing line known as impost. Next one is bed joints. The joints between the versailles which radiate from the center. Next one is center or striking point. So, what is this? The geometrical center from where the arc forming the extrados, arc ring and intrados are described or struck, known as center or striking point. Next one is span. The clear horizontal distance between the support is known as span. Next one is rise. The clear vertical distance between the highest point on the intrados and the springing line known as rise. Next one is depth or height. So, what is depth or height in an arch? The perpendicular distance between the intrados and extrados known as depth or height. Next one is thickness. So, the horizontal distance measured perpendicular to the front and back faces of the arch is known as thickness of the arch. Now, we will discuss stability of an arch. An arch transmits the superimposed load to the side wall, which is known as abutment, through the friction between the surface of the versailles and the cohesion of the mortar. Every element of the arch remains under the compression and must also withstand transverse shear. An arch may fail due to several reasons. We are going to discuss those reasons. First reason is crushing of the masonry. If the compressive stress or thrust exceeds the safe crushing strength of the material, the arch will fail in crushing. What are the material used in arch? It is masonry units and mortars. Therefore, the material used for construction should have adequate strength and the size of the versailles should be designed to bear the transmitted thrust. The height of the versailles should not be less than 1/12 of the span. Now, for the span up to 1.5 meters, a 20 centimeter thick arch ring is sufficient, while span between 1.5 to 4 meters requires a 30 centimeter thickness. Span between 4 to 6.5 meters requires a 40 centimeter thickness, and for a span exceeding 6.5 meters, the thickness at the springing should be increased by about 20% of the thickness at the crown. Now, second failure criteria is sliding of versailles. To prevent sliding due to transverse shear, versailles of greater height should be provided. The angle between the line of resistance of the arch and the normal at any point should be less than angle of internal friction. Now, the next criteria of failure is rotation of joints. Rotation can be avoided by ensuring that the line of resistance remains within the intrados and extrados. The line of thrust should cross the joint away from the edge to prevent the crushing of edge. Now, we will discuss classification of arches. Arches can be categorized based on various criteria such as shape, number of centers, workmanship, material used in the construction. Let us discuss first classification based on shape. According to their shape, arches can be classified into the following type. First one is flat arch. A flat arch typically forms an equilateral triangle with its skew back at a 60-degree angle to the horizontal plane. Although the intrados appears flat, it is given a slight camber of about 10 to 15 mm per meter of the opening width to accommodate minor settlement. The extra doors, however, are kept flat and horizontal. Flat arches are suitable for light loads and are generally used for a span up to 1.5 meters. Second one is segmental arch. A commonly used arch in building, the segmental arch center lies below the springing line, resulting in an inclined thrust to the abutment. Next one is semicircular arch. This type of arch is a variant of the segmental arch with its center located on the springing line, forming a semicircular curve. The thrust is perfectly vertical due to the horizontal skew back. Next one is horseshoe arch. Shaped like a horseshoe, this arch includes more than a semicircle and is primarily used for aesthetic purpose. Next one is pointed arch. Pointed arch is also known as Gothic arch. This arch consists of two arcs of circle meeting at the apex depending on whether it forms an equilateral or isoscale triangle. Now, if it forms an equilateral triangle, it is termed as equilateral arch. If it forms isoscale triangle, it is termed as lancet arch. Next one is Venetian arch, a type of pointed arch with a greater depth at the crown than the springing line is known as Venetian arch. It has four centers, all are positions on the springing line. Next one is Florentine arch, similar to Venetian arch but with an semicircular intrados. This type of arch has three centers, all situated on the springing line. Next one is relieving arch, constructed above the flat arch or wooden lintel. A relieving arch provides additional strength, means this kind of arch is constructed to increase the strength of existing lintel. The ends should be embedded into the abutment sufficiently to maintain stability even if the lintel deteriorates and requires replacement. Next one is stilted arch. This arch consists of a semicircular curve with vertical portions at the springings. The center of the arch is on the horizontal line passing through the tops of the vertical section. Next one is semi-elliptical arch. As its name suggests, this arch is shaped like a semi-ellipse and may have either 3 or 5 centers. Now, the next head of classification is classification based on number of centers. Arches can be classified by the number of centers used in their construction. The first type is one-centered arches. It includes segmental, semicircular, flat, horseshoe and stilted arches. A perfectly circular arch known as bull's eye arch is also in this category and is commonly used for circular windows. Second one is two-centered arches. Pointed arches fall under this category along with the semi-elliptical and Florentine arches. Next one is three-centered arches. So, elliptical arches belong to three-centered arches. Next one is four-centered arches. So, Venetian arch and Tudor arch are example of four-centered arches. Next one is five-centered arches. So, these arches are characterized by five center and typically have a semi-elliptical shape. Now, the next head of classification is classification based on material and workmanship. So, based on material used and the quality of workmanship, arches can be classified into three main categories. One is stone arches, second one is brick arches, third one is concrete arches. Let us discuss stone arches. Stone arches includes rubble arch and ashlar arch. So, what is rubble arch? Rubble arch constructed from roughly shaped stone set in mortar. Rubble arch are suitable for a span up to 1 meter and are often used as relieving arch over wooden lintel, as we have discussed earlier. Next one is ashlar arch. What is ashlar arch? Ashlar arch made from fully dressed stone shaped into voussoirs and set in lime or cement joint. For depth up to 60 centimeter, the voussoirs are made to the full thickness of the arch. Under the classification of material used, next one is brick arches. So, brick arches includes rough brick arch, etched brick arch, gauged brick arch and purpose made brick arch. So, we will discuss each of them one by one. First one is rough brick arch. So, rough brick arch constructed with ordinary bricks without shaping them into voussoirs. The joints are wedge shaped, leading to a less refined appearance, which makes this type unsuitable for exposed brickwork. Next one is etched brick arch. Bricks are cut to wedge shape using a brick X, resulting in uniform radial joints, though the finish may not be highly polished. Now the next one is gauged brick arch. Gauged brick arch made from precisely cut bricks, often soft bricks, shaped into voussoirs. The joints are fine and thin and lime putty is used for jointing. Now the next one is purpose made brick arch. Bricks are specially manufactured to match the shape and size of voussoir, ensuring a high standard of workmanship. Under the head of classification based on material, next classification is concrete arches. It includes precast concrete block arches and monolithic concrete arches. So, what is precast concrete block arches? These arches are constructed using precast concrete blocks shaped into voussoirs, key blocks and skew backs. The precision in shape results in thin joints and a clean appearance. Next one is monolithic concrete arches. These arches are cast in situ using either plain or reinforced concrete, depending on the span and the load suitable for the larger span. The formwork is removed once the concrete has adequately cured and hardened. This lecture covered the essential topics of lintels and arches, two crucial structural elements in building construction. Lintels are horizontal support placed above the opening, such as doors and windows, to bear the load of the structure above. They can be made from various material including wood, stone, steel or reinforced concrete, and are designed to distribute the weight above the opening, preventing any structural collapse. Arches, on the other hand, are curved structures that span an opening and support the loads from above. Unlike lintels, which are straight, arches distribute weight through their curved nature, allowing them to span larger opening without the need for additional support. The lecture discusses the different material used for arches such as brick, stone and concrete, and outlines the three primary stages of arch constructions: installation of centering of formwork, laying or casting the arch and the removal of centering. So, overall this lecture provides a comprehensive overview of lintels and arches, emphasizing the importance of proper construction technique to ensure the structural integrity and longevity of these elements in building project. So with this, we conclude this session. Thank you all for your active participation today. We look forward to discussing the next topic in our upcoming class.